And welcome back to Neural Notes. Today we have another special guest, Charles Packer, who's a PhD student at Berkeley, working with Joey Gonzalez at the Berkeley Sky Lab, formerly known as the RISE Lab, who will tell us about his seminal research overcoming context windows. This is something that anyone building with a language model would be very familiar with. The title of this research is MemGPT, towards LLMs as operating systems, which is effectively an OS or an operating system inspired LLM for virtual context management. And I think in another interview, Charles described it as an agent that knows how to use memory management tools. So I'm going to pass the mic to Charles to introduce himself. Thanks for coming, Charles.
Yeah, thanks for having me. Yeah, like you said, the recent work we're doing is really about memory management, and the way we frame memory management was very much trying to mimic an operating system, like a computer where you have usually only 16, 32 gigabytes of memory, but you're consistently, like every day, working with files that are much, much larger than that, and kind of trying to distill some lessons from how we do that with operating systems into language models, where we're working with language models that have like 8K context. It used to be 4K, that's really small, but now usually 8K, 32K, 128K, and that's still pretty small. So how do we work with much larger documents that are never going to fit in 128K, 256K, even 1 million tokens? And yeah, just borrowing ideas from operating systems that we already kind of have down pretty well.
So let's double click on that. So talk about how operating systems manage memory today, and then use those core intuitions to introduce MemGPT and really the inspirations behind this paper.
Yeah, so in operating systems, we have this concept of a memory hierarchy. So basically, the faster the memory gets, the smaller it gets. So on the CPU, you have registers, you have caches. These are incredibly small, but also incredibly fast because the memory doesn't have to move very far from where the compute is happening. And as you know, engineers, maybe we're most familiar with the caches on the CPU, but then also RAM and disk. And RAM, like I said, usually on most computers is going to be like 16, 32 gigs. Disk, it would be your hard drive, and that's usually like a terabyte or so on like a modern MacBook. And yeah, like I said, you're using files like every day, or working with, Chrome itself can easily like blow up to far over 32 gigs if you have several hundred tabs open, like I know many people do. And your operating system doesn't just like crumble and come to a complete halt when you run out of memory. Right? The operating system is behind the scenes, like moving memory from RAM to disk, back and forth, paging it in and out, so that you can have this kind of illusion of as much memory as is effectively on your disk, so like 1 terabyte, right? And once you fill up the disk, then you have real problems. Then your computer might say, hey, look, we're out of space. You got to free up some storage, otherwise your computer will stop working. I think Mac OS even gives you a message that says your computer will stop working soon if you don't do something about this. And then distilling that into LLMs, I think the memory hierarchy is much smaller because we're not talking about like 3, 4, 5 levels. It's just what fits into the transformer architecture's input and what doesn't. And what doesn't can just be considered like everything else, right? At that point, you can store it anywhere. You can store it on RAM, you can store it on disk, but it's always going to be just the speed difference is just going to be so big that you can just really think about it as like 2 different levels of a memory hierarchy, like what fits in the transformer and what doesn't. Yeah, there's then borrowing very similar ideas of like paging memory in and out, so that when you're building an application or some sort of agent on top of a transformer that has limited memory, having the illusion that there is no limited memory, that it's as big as like a terabyte or however big like the real storage backend is.
Got it. So obviously in an operating system, there's a CPU that does all of this seamlessly while also running your program, correct? So the program is doing the execution and the CPU is handling this, the memory paging or the caching, right? In this analogy, let's suppose that I'm using OpenAI's like, public LLM, for instance, then would you use the same LLM for doing both of these tasks, which is actually solving the application that you're seeking to solve, or continue the chat that you're supposed to engage in, and also doing the memory management? Is that the idea?
Yeah, that's a great point. Yeah, so that is the idea. Yeah, so with MemGPT in particular, we use the same language model for everything. It's the same language model for doing the tasks that you are just using the language model for, what maybe is entertainment or maybe some productivity tool. And that same LLM is also managing memory behind the scenes.
Got it.
And yeah, I think the ideas in MemGPT, like the paper, are a little bit more broad than that. It's really just about having virtual, like instead of the context window, now we have the virtual context window.
Right.
But the actual implementation in our in like the reference code for our paper is using one LLM for everything. But I think if you wanted to like productionize this, you might use multiple LLMs. Like one does the real task and another one asynchronously manages memory and so on.
So that's sort of the virtual context that you're talking about, which feel transparent to the user oftentimes, basically. Right?
Exactly. Yeah. So the user can have a conversation that goes far past like 8K, and it never feels like they really hit a limit anywhere. It's all very behind the scenes. Same with a document. You can load a document that's far larger than 8K, but you don't have some immediate realization that you've hit a limit under the hood.
When you and I were reading the paper, there were a number of terms which are very specific to the MemGPT implementation. Do you want to chat about those?
Yeah, so basically within the transformer itself, so maybe the first kind of distinction is everything that's held inside the transformer's context window and everything that's held outside. Right. So we call the entire thing together virtual context, and that's just mimicking the virtual memory that we already have. But once you make that distinction, then you have kind of the like internal context effectively and the external context. And there's a lot of different names you could use. I think if you're trying to mimic like the operating system metaphor, then you would also use like physical context versus external context or slow context. I don't think that the naming in particular is super important. What is important though is that once you're talking about what's inside the transformer context window, you have to be pretty specific that you're going to start dividing it at this point, because we already divide the context window in almost every single LLM-based task that we have. We already talk about like system prompts. I think the new version of Claude just came out and they have started to expose system prompts now. And they're saying, this is something that ChatGPT did a while ago, but with every single like inference pass of the LLM, there's always going to be a big block of tokens at the front that specify how the LLM can be more customized, right? So we have the same thing, the same notion in MemGPT. The only difference is that you have to include a little bit more information, because the LLM has to be, if you want to give it the ability to manage memory, you have to tell it up front all the different ways it can manage memory. And also you have to tell the LLM too that there's an 8K context window, for example, or you have to give it the specifics. In the same way that an operating system, even though you have the illusion of infinite virtual memory, the operating system has very specific details, right? Yeah.
Yeah. So those are sort of like the system's instructions, basically.
Precisely, yeah. So this is effectively the system prompt, as Anthropic or OpenAI would call it. We also have a working memory scratchpad that we include. This is very specific to MemGPT. It's basically a block of tokens that we designate are going to be used for, we call it working memory. It's just a place where if you need to store information while you're shuffling memory around, you should keep it here. And another important purpose for this is it also allows for further customization. So if we're talking about MemGPT applied to chatbots, a very important thing is that the chatbot should always be conversing with the user as a very specific persona, and like a persona that maybe has accumulated lots and lots of knowledge over time. But of course, if you don't include any of this like distilled knowledge about the user over time into the transformer inputs, this will not be incorporated as part of the outputs. So you do need to also designate a chunk that's just for like these long-term memories, but also scratchpad memories. And the last part, it's basically just everything else where like now you have a budget of 8K, you reserve some for system prompt, you reserve some for working context. And now the leftover can just be the rolling conversation window, or I guess in the case of like a document analyzer, it would be like chunks of documents or RAG context, that sort of thing.
How do you determine what goes into the system prompt? Like, is that an iterative process and dependent on like a specific set of tasks, or is it something that you define once and it's generalizable to anyone who wants to use MemGPT?
And so the system prompt was initially developed very iteratively, like most prompt engineering is, right? So we had like a set of functions and we were iterating over the system prompt to try to get the behavior that we wanted. So we wanted this behavior where the LLM knew how to move memory back and forth, and it knew that it was running out of memory when it was running out of memory, and knew that it was okay to not do memory operations when it had plenty of space, those sorts of things. So that all goes into the system prompt. You have to be like in plain English telling the language model here are the ways you can start, here are the ways you can handle memory, here are the ways that you will be informed by the system, like the OS layer, that you are running out of memory, those sorts of things. But yeah, you're right that like system prompts are often used by people to customize their agents to be very specific to what they want. And in the open source project, we expose our system prompts. They're not secret or anything. You can open the file, and we also allow people to customize them. So they can customize it to be, instead of saying at the top, you are memGPT, you can customize it. If you want it, this is Apache license, so you can go use it for your own company, and then now call it, you are a VC bot, or you are a document lawyer bot or something, right? You don't have to use the memGPT terminology anymore. But we did try to like segment a lot of customization that people usually want into something we call like the persona block. So this is very much just how the personality of the bot, maybe its character traits or whatever. And we put those into the working memory. And part of the reason we put into working memory or working context is so that the bot can modify it itself. So we even put like in the descriptions for the default bots, like the chat bot or the document analyzer bot, instructions that to the LLM that you can modify this. This is like just the beginning of your persona, but you should update it if the user requests it. A big distinction between what's in the system prompt and what's in now this like working memory is that the system prompt is locked. The LLM does not have the capacity to edit it. If it did have the capacity to edit it, I do think eventually with enough iterations, you would just go off the rails because the LLM would corrupt its own system prompt. So you have to kind of like block off some of this to not be editable. But the user can edit it, of course, if they want. Yeah.
What function are you passing to move memory from type of memory to another, from the internal context to external context, or from external context to, disk for archival storage, for instance, right? Yeah. These functions, are they generated on the fly during a conversation, or are they sort of pre-wired at the start?
Yeah, so the functions are pre-wired. If you worked with LLMs before OpenAI's chat completion format, you might be familiar with like transformers are just text in, text out. Now everyone's using like this high level abstraction that's a little bit confusing, but it's still all comes down to like boiling it down into or compiling it into text in, text out.
Right.
And the functions, if you want to give an LLM ability to call them, they have to be somewhere in that text. And OpenAI, they don't tell you exactly how they compile it down to text, right. But in our case, we compile it down in a YAML schema. So basically, you provide ahead of time the functions that might be like core memory append or core memory replace, and then you have doc strings. And those doc strings and functions, they get compiled down into a YAML text block, and that text block is inserted on every single inference pass for the LM.
You've got this like very neat example where you expose some of these conversational snippets. Like this person has a birthday and the user says, my mom baked me a birthday cake. It was my favorite chocolate lava. And you can see the system prompt, memGPT, who's writing to the working context that, the user's birthday is the 11th of October. Mom's name is Brenda. Favorite cake is chocolate cake, for instance. So how does memGPT know which pieces of data to extract versus not extracting and just letting it be?
That's all done through the system prompt or a system message. The system message, if I had to break it down, so it's only maybe 500 lines of text. So you can just pop open the GitHub repo, just click through and you'll find where the text is. But just to describe it briefly for anyone who doesn't want to do that, it basically starts with a preamble that says like, you are memGPT, you're an LLM that can manage your own memory. Then it gives some examples of how you might run out of memory, that sort of thing. But it also gives a breakdown of the different parts of memory and what they should be used for. So it says like the working context or the core memory, you should use this to store very key facts like birthdays, those sorts of things. I don't think we say birthday specifically, but it kind of gives the intuition to the LLM of like what it should be pulling in and out. It also has some other instructions like if you run out of core or working context space, then you should start pushing to archival memory.
And so can you talk about all the different triggers or events that prompt the LLM or prompt memGPT to know, hey, Chase told me his favorite ice cream was chocolate and today he said strawberry. I should be mending this fact. Like, what are the categories of events like that would prompt the LLM to take some action?
Yeah. So in practice, I think a message like that where you say something that clearly should cause some updates to like a core character sheet or a core user sheet. Sentences like that with GPT-4, I think you'll have like an 80% hit rate that the LLM will identify, oh, I need to go write this to memory. With something like a Mistral 7B fine-tune, I think it's now at like a 50% hit rate. But we have like this fail-safe where basically when memory gets to a point where there's going to be a summarization event that like basically truncates the memory block, that actually is alerted, it's sent as an alert to MemGPT internally. So the LLM will see an alert that says, you're about to run out of space, make sure you write stuff to memory soon, otherwise it might get truncated out. And with that, I think you start to get to, like 90% plus, even with the open models, that they'll actually take that corrective action. Even if it forgot to write out some important facts, now with this like second opportunity or second nudge, it'll start doing some memory operations. I would say that if you had to take two high-level ideas away from the MemGPT paper about how we can think about LLMs not just as the transformer, but as like this entire life cycle of a processor inside an OS, for example, or a kernel process. The two things would be the memory part. I think that's pretty intuitive that you move memory back and forth to deal with your tiny context window. And the second part is maybe a little bit less intuitive, but it's that you abstract. You no longer think about interacting with these chatbots or transformers or agents as user input in, agent response out. You think about it at like one higher level of abstraction where you have like a continuous event loop that's running, and a user message is just like one form of input that an LLM can see. But the LLM, if it's really running in some sort of like kernel process that also can manage memory, execute functions, it should also see kind of responses from that process, right? So user messages now are just like one category of message or event the LLM will see. You have other ones that are like system messages that will be like the memory warnings. If you want to maybe build a very interactive chatbot, you can have it actually run on a timer. So you can have just timed events that happen. So this is something we did with our Discord bot where like every hour the LLM will be run kind of proactively. And the LLM itself can also decide whether or not to reply. So on the other end, so that's just talking about the LLM inputs. But on the other end, the LLM outputs are no longer just plain text, and the text is the response. The response in MemGPT, or the output, is always a function. So even when the LLM wants to communicate with the user, it has to call a function now called send message. So you get this really cool dynamic now where like the LLM can be run in the background and just decide to never engage the user, right? So you'll notice this with the Discord chatbot where the LLM just decides it can see timestamps too. So all this metadata that can be added to the events. So I'll see an event that's maybe, this is the hourly timer that went off. Here's the current time. Here's the user's location. And it will make a judgment call that says like, hey, the user's asleep. I'll wait a little bit until I message them. And so the last very important thing about this whole event-driven LLM loop is that the LLM can also decide to maintain control. So it can basically decide to call itself again in a loop. A good example would be if the LLM is trying to like maybe look for data and then reply. It can look for data with a function call, but when it makes the function call, it can always request what we call in MemGPT a heartbeat. So it can request like, hey, as soon as this is done, OS layer, please run me one more time because I need to like finish up my task. And yeah, I say that all kind of falls into the general premise, I think, of like OSs for LLMs or the LLM kernel process. And I think this is probably where things are going to move. And it's not really distinct from memory. It's like very related. These two concepts are tied very closely at the hip together.
I guess the awareness of when to go back to the user or when MemGPT needs to engage the user again is also important for like function chaining. So allowing it, execute multiple functions behind the scenes sequentially before returning control back to the user. Like, is that right?
Yeah, that's exactly correct. Yeah. So like one user input, one user message can lead to a chain of, practically you want to restrict this probably because you start to hit latency problems, but you can lead to, theoretically like an infinite LLM cycle where it just decides to retain control forever and it never yields. And yeah, it's related to like how computers work, but it's also maybe a little bit distinct now because like computers, you run with like a fixed clock cycle, right? That's like the rating on your CPU processor. But with LLMs, maybe we want to like flip this a little bit where the LLM is also very expensive to run. It doesn't run nearly as fast as a CPU. But maybe instead, like these things, they can control when the inferences happen. And they also run on a clock, but it's like an inverted clock, right? It has to be actively decided to run. I don't think we're going to get to a point where we have a lot of people talk about LLM CPUs, right, or LLM processors. They're not going to be like processors in the sense that they're running like 5 gigahertz on some data center somewhere. Right?
And the sort of chaining of functions as well, right, before responding to a user input Are those functions also put together and composed on the fly by MemGPT, or are they preset?
Yeah, so those functions are all going to come from like the function library it sees. I mean, there's nothing preventing you from re-architecting MemGPT so that it can make functions on the fly. So one thing we added recently, we released MemGPT with the core function set. It's basically 5 to 6 functions that are responsible for memory management, and then the additional functions that are more utility-based, like sending the message and pausing heartbeats. So like the agent can hit a snooze button if it's being run on a timer. But one thing we've added is now we have like drag and drop functions. So you can write a Python file and you just drag it into some MGPT folder and it gets dynamically linked to the agent. And that happened as long as you have enough doc strings. Another LLM could also write the doc strings for you. But right now, you just have to write Python that is typed and has doc strings. And if you just drag and drop it to a folder, it can be dynamically linked to MemGPT, and MemGPT can use this function. So there's nothing also preventing you from getting one step further where MemGPT can write the functions and itself like drag and drop, and update itself, right?
But that's not what you've implemented so far. Basically.
No. Also, I think when you start to do stuff like that where LLMs run on their own outputs, you hit a lot of bugs.
Right. And you're also kind of in compiler land at that point, correct? Because you have how to compose the sort of tree of functions, to respond to a particular higher order task.
Exactly. So I think right now, like what we support is people who want to add new functionality. So like opening and closing Jira tickets was one. So they can just write the Python functions that do that, drag and drop it, and GPT can call those for it.
For sort of a typical conversation, how soon do you run out of context? Right? Obviously, there are context windows which are 100K long right now, or maybe in the future, almost 1 million, right? For sort of the implementations that you have seen in chat or in conversation, give us some numbers of how important is this, or why do people care in the context of conversation?
Yeah, I would say maybe a few months ago when the best open models were 4K, you would run out of context maybe in a few dozen messages, maybe even like 2 dozen. Right. And yeah, that's like shockingly little. And when you go to 8K, I'd say most people these days, if they're running like state-of-the-art language models on their laptop or something, like open models, they're probably using an 8K context window model. At that point, you can maybe send like 40 messages before you start to run out of space. And with MemGPT, you also incur this like fixed cost of maybe 2.5K tokens that are going to be used upfront for system instructions, for memory, for the function schema, all those sorts of things. But I think when you hit the 100K or 128K, 256K, I think you can probably go up to like hundreds of messages, I think, at that point, before you will trigger an event, like an out-of-memory event with MemGPT. I think, so with chatting, I would say that for like a chatbot that you maybe would want to use daily, and then you don't really care about retaining memory after that, a 256K model can probably meet your requirements there. But if you want to have multiple times per day, multiple days in a row, then you will exceed that pretty quickly as well.
It's a good point at that time to like checkpoint the memory and store, the context or the conversation that we've had so far in this sort of virtual memory before recalling it again. Yeah.
I think one nice thing is as you make the context windows larger, then you have to do memory management less frequently. So right now, if you're using an 8K model with MemGPT, you actually you'll trigger memory events maybe every 2 or 3 dozen messages. And if you're running everything on the same LLM thread, if you want to call it like a thread here, you will notice the latency. So you'll basically, every few dozen messages, you might say like, oh, what's going on? Like the bot is taking a really long time to think. And what it's doing is it's like reading and writing back from memory. Yeah.
You mentioned the 2.5K token tax. Do you have ideas, or are there efforts underway to try to like bring that down? I realize in the scheme of things, it's not a huge part of the window, but as you start to scale up applications where that hits every time, it is literally a financial tax on these AI applications.
Yeah, absolutely. The only way to really solve that is you fine tune specifically for MemGPT. My only concern there is, I guess it's a matter of trade-offs, right? If you really have gone to the point where you have like some very stable system in production and you're trying to shave costs, then maybe, getting rid of that 2.5K token tax makes sense, because in the long run, it'll save you a lot of money. But the big issue with fine-tuning to remove that tax is that you're not going to be able to do stuff like dynamically linking functions anymore. Or the model might be a lot less flexible at that point to incorporating new functions if you fine-tuned it on a ton of examples of just like a core set of 6 functions. Another way you can get rid of the tax that's not fine-tuning related is you run LLMs in parallel. So you don't have like one LLM do all the memory management. You offload that to another LLM that has the same, now it maybe has like a 1K token tax. But that LLM doesn't get run every single inference call. It gets run like one every 8 times. So that's another way you can get rid of it. But yeah, like I said, I think right now, because context windows are growing pretty reasonably, if you can stay at a fixed like 2K tax, 2.5K tax, I think at that point, a lot of people will not even want to deal with the hassle of fine-tuning a model. Yeah, it's a lot of energy and work to fine-tune something, and then the next week, the next open model blows it out of the water with in-context learning or something.
I guess there's two shapes of memory management problems. There's one, I've got a long conversation back and forth. What about like long documents? We start to get into the realm of like retrieval augmented generation and how people use that technique to overcome the long document limitations. Like, how should I think about these two different techniques side by side and then potentially used together?
Yeah, so I think documents is a place where maybe the long context thing is like a very immediate issue, right? So with chatbots, the long context problem, you can kind of motivate it with like, in the future, or maybe like once we have the long context handling down, then people will use chatbots as like personal companions or personal assistants for years, and they'll have the same chatbot. But that's like a hypothetical future, right? With documents, it's like a very now problem where sure, like the new Claude has like 200K context and they can support, maybe 500 pages, I think is what they say. But there's plenty of times when you want to like collate data from, terabytes of documents, right? And that, if you think about what I think if you do the numbers and like what actually fits in 128K or 200K, it's like a fraction of a megabyte if you just like text that's UTF-8 encoded or something. So it's actually very small. So when you talk about like doing operations over like terabytes of data that a company might have, I think you can't just, in my opinion, you can think about RAG for this, but the amount of space you have to do RAG, like in context RAG is quite small still, right? Like 256K is just not that much. And if you're relying a lot on the embedding search or the vector search to be good, it's very easy for like the target document you're looking for, the target information to fall out of the context. And a lot of people who are like more in RAG, they're working like very hard on making the retrievers better, right? So the retrievers are getting much, much better. A lot of it's centered around embeddings and like query refinement, that sort of thing. And I think both the improvement in the retrievers can be combined with ideas from MemGPT. I think the way you think about MemGPT and compared to RAG is like MemGPT is about using tools. So naturally, if you're in like the tool using agent land, how will an agent research or do search over documents? It will use tools like the search tools that it gets exposed to. And if you have these really, really retrievers that were built out for your own company's data or your own personal data or whatever, then you can just connect those tools to MemGPT. Like you can just give that exact same retriever as a tool to MemGPT and it can use it. And it can actually, you can start to get advantages where you have built-in query refinement, right? Because MemGPT knows how to refine queries because it's very conscious that it's using tools. So even when we did earlier experiments with MemGPT, like in the paper, MemGPT doing document analysis, you see query refinement happening in real time. So MemGPT will like do 5 pages of searching and with the user query, and then it might say, okay, look, the results aren't looking very good. I think I should refine my query. And it just has this thought to itself and it refines the query. So in the meantime, like if you want to do query refinement without this tool using paradigm, you have to bake it into some very complex workflow, like RAG workflow.
And you could save it as a routine, basically this query refinement process, and you could run it as a background function almost. That's what you mean by a tool.
Precisely, yeah. So I think you can take like all the advances that have happened in RAG and connect that pretty easily to anything that's like agent-based, like MemGPT.
Talk to us a little bit about sort of the sets of tools that you guys have right now in this sort of tool belt, and where is research headed in terms of new tools that you're envisioning implementing MemGPT?
Yeah, so right now the tools, there's the initial tools that we are calling just like the core memory management set, and then there's also the core like utilities set of tools that is like sending messages, sleeping, automatic cycles, that sort of thing. And I think what we're looking to build out in the immediate future is tools that are very much just driven by what users kind of want in their own workflow. So one thing we're noticing is a lot of people want to use these sorts of chat with your doc agents kind of as like co-editors for a lot of documents. So they want their agent to be able to like read and write from the source material, like read and write from a Notion or read and write from markdown files that are in Obsidian, that sort of thing. And that's completely feasible, like with MemGPT. You just have to write the tools to do that and package it in. You just, at that point, have to start writing like maybe Obsidian-specific Python or like Jira-specific Python, that sort of thing. So that's what we're looking to add. It's very much focused on workflows, like what people really are using this for. But I think like in the longer term, the tools might start to look a little bit more dynamic, where you delegate this tool use to other LLMs. I think it's a little bit intractable. Like ideally, you want like not only a MemGPT or an agent that can use Notion, that can use Obsidian or whatever, but it can use like anything that is documented on the internet, right? And to get there, I don't think you can just write the schemas and dynamically link like every single tool and stuff it into a context window. So you have to start thinking about delegation properly. So maybe not only delegating like these background kernel processes like memory management to other LLMs, but you can also delegate the tool use to other LLMs. So the user can just say up front, hey, we're going to like edit a Notion together. And then immediately there's like a dispatch that happens that says like, bring me all the tools for Notion and put them in my working memory, right? And I think that's kind of the longer term agenda with these things. But for the immediate future, you can build a lot of these things out as like very specific libraries and then still get a lot of utilities. So we'll see.
When do you expect to have GT work with perhaps some of this more sophisticated sort of multi-tool calling or sort of chaining of functions? You know, how does it look like? I don't want to hold you to a deadline. Your advisor does enough of that already.
On the tool side, the dynamic linking thing actually was just released like last week.
Cool.
So yeah, this is the thing. So already right now you can like clone MGPT and you can follow the instructions on the documentation for it. If you just write Python, make sure it's typed, make sure it has a doc string, drag and drop, and it can get linked to your agent. And like obviously you could do this kind of in the general scheme of like OpenAI function calling, but it was never this like clear that you can just handle the execution in like an execution layer. All it requires is that you just write Python. So I think this is super cool. I think this is the first kind of version of this I've seen in the wild. So we're really excited about that. But the other thing we're really focusing on for the short term is better support for local models. So right now, we're noticing that a lot of people just want to use local models. A lot of it's cost, some of it's privacy, and a lot of it's also just that the models are so good right now. Like you have local models that are GPT 3.5 turbo quality. So it's kind of a why not, right? And then a lot of people have MacBooks that can run this reasonable decoding speed.
I mean, you could almost sort of see just a process handling, MemGPT specific LLM, which could potentially run locally, and then you could probably have a more generalized model, in the cloud or with somebody else, for instance, even. Right?
Yeah, exactly. Yeah. So we have some work on fine-tuning models that's ongoing right now. But we're also finding that these open models that are coming out with a cadence of like one new one per week, they're really good. And yeah, they can already do function calling really well. But we're also releasing this chat UI. This maybe should be out like next week. But this is just a very clean interface. So a lot of people, they don't want to use a CLI, right? And it's a little bit ugly. It's harder. Everything's just like less sticky if it's like a CLI, where there's a lot of UX stuff that you get with a real, like JavaScript project or something. So we have this front end where we should be releasing next week. But yeah, apart from that, I think really the tool use thing is our biggest agenda. So it's like UX related, just so that people can use these models a lot easier, because you have these like chat wrappers that are really meant for just chatting, but MemGPT is a lot more than that, right? It's about document ingestion, syncing to your own data, running these things on timers and that sort of thing. So yeah, the tool use I think is going to be something that we have the initial version out right now, but we're going to be trying to add, it's almost like a plugin store, right? Add as many high utility kind of pre-written tools that you can use.
Okay, one more question. Have you released a plugin, quote unquote, for Gorilla yet?
So Gorilla, I think that's a cool way to think about it actually, right? You could also just have Gorilla connected as a plugin. We have a plugin, I think, or a tool that's called Message ChatGPT, where you allow the agent to also just call a ChatGPT, which is kind of hilarious if the agent itself is using GPT-4, right? But it ends up like, some level of indirection like that can actually be useful. But yeah, you do the same thing, like call the Gorilla helpline, to get the API spec. Because if you have something like Gorilla, then you allow for like arbitrary HTTP requests to be sent out. You can always like interface between the two. Like you ask Gorilla for the HTTP it should be sending, and then you route that out to the HTTP tool, something like that. It could probably work.
That's wonderful.
Amazing.
Well, no other questions here, Charles. We really appreciate you sharing a little bit about the work, and I suspect that all of the listeners and viewers will appreciate this. Where can they find you and your work?
Yeah, so MemGPT, you can go to memgpt.ai and you should find all the links like the GitHub and everything, data from the paper. And if you want to contact me, probably just DM me on Twitter, shoot me an email at my cpacker at Berkeley email. Either of those will work.
Awesome. Cool. Thank you very much.